Well, good morning. So when Clint asked if I would speak to about information management to a room full of building information experts, I wondered what possible remarkable insights I could offer. So what I'd like to do is share some of my experiences in implementing information management and decision management solutions for the oil and gas and aerospace industries, and then contrast that to what I'm observing in the construction industry. So Scius is an R&D company that's working to develop strategies for information management for the built environment. Oh, it appears that my slides are out of order. There we go. So our industry is one of the largest manufacturing industries in the world. We have a large number of independent companies that are involved in the design and the construction and the operations of the building. But this results in this information fragmentation. There's bits of information all the way through the life cycle, and they're not often shared. So the result is our industry is not as efficient as it could be. And it results in buildings that may be more expensive, take longer to build, longer to commission, don't perform as well as they could, or are not operated as well as they could. And this leads me to the question is, what could we achieve if all of this information was available to all the stakeholders throughout the life cycle? So other industries have struggled through this, and I'd like to share some of those experiences. I'm just going to skip through some slides there. Okay, oil and gas. Their engineers also build 3D, 4D models, just like a construction industry. But these are subsurface models, structures under the ground. And these models, by comparison, are enormous, usually petabytes in size. They integrate many different disciplines, including geologists, engineers, geophysicists, production engineers, many different disciplines. But in their case, those disciplines often reside in a single company, unlike our industry. So they build these asset teams or ecosystems within the organization to work on a specific project. And these ecosystems are very dynamic. A team will get together, work on a project, and then they'll disband and they'll work on another project with different people. And sometimes those people don't work for the same company. It doesn't matter. We're all working together on this project. So oil and gas has struggled with the same questions that we struggle with. Am I working with the right data? Is it the most current, correct, complete? How do I keep my models up to date? All the same questions that we have. The oil and gas industry has developed assets that have the same financial value as buildings, so tens to hundreds of millions of dollars. They have the same life cycle, 50 years, just like our industry. And they've needed to integrate all these different disciplines, just like our industry. But what they have done is they've developed this culture of collaboration and a strong belief that information is critical to drive business success. Okay, so how has that industry dealt with these challenges? Well, oil and gas went digital almost as soon as computers became available in the 1970s, and that really accelerated in the 1980s with the introduction of mini computers. And very quickly we realized that we needed a standard for hosting data. We needed a common schema. The technology of the day back in 1980 was, a relational database. It was revolutionary. So what the industry did was to form a consortia to develop a standard schema, standard data model, and all major applications were based on that schema, which made things enormously easy to move data between applications. So that took care of our structured data. But the unstructured data, the documents, was still out of control. So in the 1990s, the industry again formed a consortia to develop standards for the business processes, which then led to the development of a taxonomy for the documents or the work products within those processes, and eventually led to the development of an ontology. So for those not familiar with the term ontology, it's a set of concepts in a subject area that also describes the relationships between the concepts. So an ontology, for example, it allows you to find content based on the context. So for example, I don't know what it's called, but I'm looking for a document that was created by the geologist during the design phase, and it was submitted to the regulator, and the ontology would come back and say, oh, you're looking for the geological prognosis report, and here it is. Right, so you can find things on context. In the late 1990s, the major software vendors and the oil companies all got together and collaborated in the development of a single common API that supported any data in any system. Massive effort. And it led to the development of a single common application store, which meant that small vendors like myself could develop creative ideas and get those into the market without having to be a major vendor. So with this culture of collaboration spanning decades, and with the introduction of social networks then, the industry started to develop these collaborative ecosystems, which I'm going to harp on this in this talk. And we found great benefits with tighter integration between the oilfield services companies and the oil companies. So something that's a bit different in the oil and gas industry, which is different than our industry, is that nothing is really known about the subsurface until you poke a hole in the ground and you see what's there. So there's a ton of unknowns, and these models that we would develop, there's no such thing as an as-built model because you don't know what's down there. But if you, when you start drill the holes, you get more information, the models are updated, and it creates the problem is that today's model is not the same as yesterday's model, and it continues to mature. But I'm making decisions today on the information I have today. That information is then made obsolete with new information, and then people might come back and say, well, given this model, why the heck did you make that decision? And so this gave rise to the need for results management, so I could keep track of what the result was when I made the decision, who was involved in the decision, what information did we consider, and why did we make that decision. So in the end, this industry has spent hundreds of millions of dollars over the last, 30, 40 years on information management. And even today, each oil company spends between $1 and $10 million a year on information management technologies. So in the end, what did we get from this investment? Well, one significant benefit, I'm not going to go into all of them, but one significant benefit was the development of this culture of collaboration, which has injected creativity and innovation into the industry. So given a belief that information is an asset, an executive belief that information is a corporate asset, then they've invested a strong commitment of time and financial resources to information management. And then the development of these interoperable frameworks, and then add the development of a common application store so that small creative companies can inject innovation. And the result was that you develop this ecosystem of small creative companies that had then a route to market. Okay, that was my experience in the oil and gas sector. Let's take a look a little bit at aerospace. Aerospace also builds 3D, 4D models. They're very large volumes, not nearly as large as oil and gas. But this time, they have many interdependent stakeholders, but they all work for different organizations, just very common, very similar to your industry. But what's different about the aerospace is that all those stakeholders, the owners, the engineers, manufacturers, and what have you, they're interested in that asset, that aircraft, through its entire life. They don't let go. It's not like in our industry, the architect will do their job and then they'll let go. And then the engineers will do their job and so on. I'll build the building, it's now up, here's the keys, I'm done. In this industry, nobody lets go. For example, when I visited the design team at Bombardier, they were keenly interested in the performance data of their older aircraft, and they've built sophisticated systems to track enormous data. Every time that the pilot has his hand on the throttle, it measures the pressure of his hand on the throttle to know just how that plane was being operated. It's extraordinarily detailed. And the insurance companies, they can manage their risk and reduce their premiums if they can track how that asset was being operated and how it's performing. So if that asset is being operated gently, it's going to have a longer life cycle, the insurance premiums can go down and so on. Okay, so the aerospace industry also has these high-value assets, $10 million, $100 million. They're very long-lived assets. We still fly in planes that are 50 years old. Very large volumes of data in their models and their documents. They need to integrate all those same disciplines. What they have differently, though, is a strong belief that information drives safety in the industry. And so they're very, very safety-focused. So what did they do? Okay, well, very similar to oil and gas, they implemented standards in their data in the very early days and provided those standards for information exchange. They developed a taxonomy for their unstructured documents, but it's not clear that they ever got to the stage of developing an ontology. That's still up in the air. Aerospace achieved the sharing of aircraft performance data because that spoke directly to industry safety, right? That was a key driver. However, the culture of the industry also had almost a military secrecy about it. So they haven't developed this culture of intercompany collaboration that the oil and gas sector did. And so the result is that any innovation in the industry is going to be limited to the capabilities with any one organization. And that's a shame. Okay. So one of the lessons that we've learned in the oil and gas, aerospace, and other industries that I've worked in is that developing these information management solutions for a variety of industries, the importance of these collaborative ecosystems. So think back now, 1,000 years ago, we were artisans. We could build, I could build 2 wagon wheels a week and provide those to the industry. But then society expanded through the agricultural revolution, and there's a demand for higher volumes and lower cost, right? So now the market is expecting me to build 200 wagon wheels in a week at half the cost. So this introduced the Industrial Revolution and the hierarchical structure to the companies that have served us really well for about 100 years. Notice that the Agricultural Revolution was 1,000 years ago, the Industrial Revolution was, say, 100 years ago. But as mass production techniques were refined, these low-cost manufacturing centers pop up around the world. And now the company that's making those wagon wheels can outsource that to a low-cost center. And the challenge now was that the consumers didn't want to buy a wagon wheel. They wanted to buy a more complex product. They wanted to buy a car, but they wanted to have different kinds of cars for different purposes. So this integration of complex system has led to the matrix organization, which integrates vertical markets with your disciplines, domain experience. And that's the kind of structure that we all seem to be working well in today. But these hierarchical and matrix organizations can't keep up with the velocity of change in our industry. I mean, we all complain that innovations are just coming so fast, we can't keep up. So the structure that's emerging to address this velocity is the ecosystem structure. And we've heard that word so many times today. And this is going to support what I'm calling the creativity revolution. And notice now, the agricultural revolution was 1,000 years ago, industrial was hundreds of years ago, information was tens of years ago. You see an order of magnitude change for each one of these revolutions. And I think that we are now in this creativity revolution. So by establishing these smaller groups of stakeholders that work collaboratively together on a common project, you have to align the business objectives. These people don't necessarily work for the same company in these ecosystems. So now you need to align their personal objectives and their corporate objectives in some manner. Actually, a little aside, I was intrigued with Dermot's talk this morning where he talked about the common. So that's a physical space where people can come together, and it's fun and it's creative, and it's a space that encourages these teams to come together and work together. And I never thought about these ecosystems having a physical dimension to them. I always thought it was more of a cultural dimension, but that was intriguing. Okay, so how can we approach this challenge? Well, first of all, I'd like to define what information management means. And an information management strategy provides the culture, I'll underline that word, the governance, technology, processes, information to get a community of knowledge workers to come together and collaboratively develop solutions to deliver results on a project. So to develop these strategies, there's 3 major steps. And this was common for all the industries I've worked in. The first, we need to define the business objectives, the goals of the organization, and the KPIs that they're going to use to measure success against those goals. Second, we want to discover, what do the people in the organization do today? Are they actually going to achieve those business objectives? You'd be surprised how many times people are doing things that actually don't align with the business objectives, and we need to, part of that process is to make that realignment. We need to understand what work products are created in that process, who collaborates on developing those work products, and the cultural issues that prevent people from working together to get that done. So once you get the deliver phase, is that phase where we begin to now realign what people are doing, their business processes and their cultural challenges, and realign those with the business objectives. So that's what an information management strategy and the methodology to build it. Another way of looking at this, I call this the top-down, bottom-up approach. You need to start from the top, understand the business strategy, understand the business processes that are going to drive results against that strategy. And then you go to the bottom and you come back up and you take a look at the data that are going to support those processes. What do people need to actually develop the work products that are required to make decisions within the processes? And I call that the decision space. So the deliver phase is what is the decision space, and it establishes the systems that allow those people to integrate and share their data. Okay, I'm running short on time. So the information management strategy does have 5 different components. You need to consider the IT infrastructure, make sure it can provide the data fast enough. We need to have trust in the data, and that's an important thing that often people will just say, well, I'm managing the data, there it is. Well, if you don't know how it got there, who is responsible for it, I don't trust it, I'm going to go do it again. Deliver that into the applications. We've been talking about the collaborative ecosystems and the culture of integration and the results management. So I'm going to skip past this in the interest of time. At least I'm going to try to. No. Is there a back button? Okay, so where should we start? It turns out that the construction industry has already started to develop some of these concepts that we need, but compared to other industries, we're well behind. For example, we're developing standards for the naming conventions that get surfaced in technologies like Project Haystack, which Chris Renter is going to talk about in the next talk. We have started to develop the industry foundation classes, which provides a common definition for the components that we use in our models. To my knowledge, this industry has not yet started the development of a taxonomy or an ontology, but I could be wrong there. The Open BIM effort is seeking to develop this common API and a standardized framework, which is an enormous and a very, very important effort. There could be other players on this screen, this is the kind of what I know about this industry. There is a great deal of effort that is spent on managing these 3D, 4D models, and that's typically done through heroics and manual effort. And hats off to those managers that keep those models up to date. But this industry has yet to develop this culture of collaboration that we see in other industries. The closest effort I can see is the integrated project delivery, or IPD, but I understand that this is actually quite rare, not used very often. But it is definitely a structure that will bring collaboration together. But without this culture of collaboration and a lack of sharing, we've got this us and them culture. And without this sharing, the industry is going to continue to suffer from the lack of creativity and the performance gains. Dermot said, you know, the last big innovation was air conditioning, and that was 50 years ago. Oh, that's a pretty tough pill to swallow. Okay, so conclusions. This sort of summarizes the whole talk. And what I've observed in oil and gas, aerospace, and the construction industry. First of all, the value of the assets that we each create is about the same. They have the same lifespan, 50 years or more. The oil and gas industry is vertically integrated to a large degree, so everybody works in the same organization, more or less. Aerospace is more fragmented, but it's tightly controlled with this culture of secrecy. And the construction industry is fragmented, but it's also non-collaborative. Information is an asset, or data is an asset. The oil and gas industry has a very strong belief that information is really what they generate. Oil is what comes out of the ground, but that's a detail. And they've invested millions and millions of dollars towards information systems over the years. Aerospace is also committed to information management, but the implementation has been somewhat fragmented. So it isn't clear how the stakeholders in our industry are going to adopt information management in the years to come. IM is often seen as a necessary evil and a part of the IT department, which makes no sense to me at all. IT will keep the computers going, but information, what's in the computers, is none of their business. It's a little bit like saying, oh, my accounting system is now part of the IT department. It doesn't make any sense. So the business drivers are in the oil and gas sectors around safety. It's unclear what the business drivers are here. Interoperability in the oil and gas sector is well developed. Like I say, with aerospace, it's very cautious. The culture of collaboration in oil and gas has been well developed. And what I would recommend now for the industry is, first, the executives in our organization needs to accept that information is a corporate asset and needs to be treated as an asset. Next, we need to significantly increase the support for our working groups like Haystack, IFC, OpenBIM, and CanBIM. Next, I feel that the industry would benefit from both the development of an ontology and a taxonomy, but this is going to require very significant financial support. And finally, I think the construction industry needs to figure out how to develop this culture of collaboration, and maybe it's an IPD or something like it, maybe it's something else. But failing to evolve to that structure is going to limit the creativity and the innovation that this industry is going to experience, and our clients are demanding. So that's it. I am almost over time.